I'm going to show you the relationship between double integrals and volume. You should recognize this. It's almost identical to something that we looked at in Calculus 1 on integrals and areas. I've taken the function z equals 1 minus x squared over 2 minus y squared over 2 on the region where x is between 0 and 1 and y is between 0 and 1. So on this square, 0 to 1x, 0 to 1y, I've graphed the function. And so the red graph is the graph of z equals 1 minus x squared over 2 minus y squared over 2. Now we're going to partition the x-axis into intervals, subintervals if you want to call it that, and each one being delta x in width. And again, here's the surface up above it. And we'll partition the y-axis the same. Again, they don't have to be equal size partitions. It just makes it easier for me to draw the graph. However, these are delta y's. So, in the region that we're integrating over, which is this square, we have divided that into little bitty squares where the area of each square is given as delta x times delta y. Now, you can see that that creates a solid whose height is the function value. So we have the volume of that solid above the little subinterval, the partition, as being f of xy, that's the function value, the height, times the area, which is delta x times delta y. So then, when we take the solid formed by subdividing the x's and the y's into subintervals and add all of those together, we get an approximation for the volume beneath the surface. So here is the region that we subdivided into delta x and delta y's, and the solids that we created, the rectangular solids that we created whose volumes are given as f of xy times delta x times delta y, which we call delta A. And so there are a number of rectangles. To get a better approximation and for this to become an integral, we need to do the limit as the norm of the partition goes to 0, which means the number of subintervals is going to infinity. And so here is what's going to happen as we get more and more subintervals. We get a closer approximation. The limit is indeed what we call the double integral. And so that's the definition of the double integral.